attention. 3.9? 3.10? I don't know. It's implicit differentiation. I don't know. So, here's the game. The game is this. Frequently, you'll run into a situation where you've got your y's and your x's inextricably linked together. Oh, this is disturbing. That's just gross. Mr. Groom, I would like to know how does y change as x changes? In other words, but you're assuming that y is a function of x. That's right. It's implied that y is a function of x. Why do we do that? I'll tell you why, Lil. Because for all of our born days, we've been doing this crap. Y depends on x, yes? So we are going to imply that that's still true, yes? But what is the function of x? I don't know. If I could solve for it, I'd tell you. Okay? Again, we call it implicit. It's implied. Back in the day, you watch a TV show, like, for instance, Leave It to Beaver or something. The lights go down, right? They go to their twin beds, the husband and wife. She's covered from head to toe, all right? So he's wearing his pajamas. The lights go down, the lights come on, and they've got 3 kids. It's implied what happened. Okay? It's not explicit, you see? Okay? Didn't need the R rating. All right, where you got to see the whole process. Okay, they putting it in and getting the baby out situation. You did not see it. It was not explicit. It was implied. Okay, you with me? So it's implied that it's true. We don't know what it is. If I knew what it was, then I wouldn't need implicit differentiation, would I? No. So here's the thing: we are going to solve for dy dx. You see this? That's what we're going to solve for. Okay. Now, it's imperative that when we do this, we probably need to do it at an actual point. Mr. Groom, what point do you want to do? Well, I don't know. I feel like I'm going to use the point 0, something, but I'm going to go look on the graph in a minute because I have no idea what this graph looks like. Okay, and it's just I made too hard of a problem right now. Okay, it's just gross. I don't know. Okay. Now, here's my question. When I take the derivative of this fella, that is a product rule, yes? So what's the derivative of y? It's dy dx times the second function. That's cool. Plus the first times the derivative of the second, yes? That's easy. Nice. Brooke, look, there's functions inside of a function. Hence we need the chain rule, yes, dear? So the derivative of ln is 1 over what's inside, yes? Times, oh my gosh, that's a product. So what's the derivative of x? 1, right? Plus the first times the derivative of the second. See? Sí, es muy bueno. Yesterday I was thinking, how cool would it be if I had okay, 2 projectors like I do, but check it out. I could have an extended desktop. I could finish this one and then sweep it over and put it over there and then start writing on this one while that one was still up there.
You can do that.
How freaking cool would that be? Can I?
Yeah.
Dude, anyway, I don't even know. But how awesome would that be? I was thinking it'd be like the 21st century version of the old flip chalkboards. Huh? I always wanted those chalkboards. They're so cool. All right, let's keep going. Hey, that's a quotient rule, yes? How do we take the derivative of quotient? It's the derivative of the top times the bottom, yes? Minus the top times the derivative of the bottom. All over the bottom squared. Equals 2. That makes me happy. There we go. By the way, you notice over here there's 3 people that did their homework, that are using their homework. One who probably did it but is not using his homework for whatever reason. And one loser. I'm just teasing. Dude, it's a homework quiz. I just want to help you. I care.
Why'd you give us this first problem?
Because it's easy?
Wrong.
Gives us the problem. He doesn't give us the clean ones. Give us the bad one.
Yeah, I didn't work it out, but my God, that's not that hard to do.
It isn't. These guys are just jokes.
Shh.
Doesn't even do the homework.
I'm just teasing. I don't care. If you have homework, I just thought I'd use it. That's all I'm saying. Whatever. Now, let's keep going, shall we? The dealio here is we want to get our dy dx's on one side and everything else on the other side. That's all for it algebraically, okay? So notice, I'm just going to leave this alone. I'm just going to leave this fella alone. I'm going to write this 2xy because it bothers me when it's not in alphabetical order. And yes, I realize that makes me a bit of a hypocrite for some other things. I know, Levi, so whatever. So when I take this times this, it's going to be y over xys plus x over xy dy dx. And yes, I know those can be reduced. One moment, please. And then 4y over y squared minus 4x over y squared dy dx equals 2. I do it that way because I really want to get my dy dx split apart so I can put all the other junk on one side and leave the dy dx on this side, yeah? Or the other side, whatever I get. Yes? All right, Lil. How many dy dx's do I have, kid? I don't know, Mr. Groom. Let's count them out. So I've got x squared of them. Huh? Mr. Groom, can I cancel these x's off here? I figure I can. So I've got plus 1 over y of them minus 4x over y squared of them. Yes? That takes care of my dy dx's. They're gone. Everything else I'm going to put on the other side. Watch me do it. Mr. Groom, can't this cancel and become 1 over x? It can. Oh my gosh, can't that just become 4 over y? It can. And what about the 2? Yeah, it's still here. Relax, dog. It's still there.
Can I use a piece of white paper to...
You can do whatever you like. Whatever you'd like. Okay.
Just show your work.
He doesn't have a problem with that. This is, friends, what dy dx equals. That's the derivative? Yes. It's gross. Yeah? What's your point? Well, Mr. Groom, some things in life aren't pretty. You're not wrong about that. They are disturbing sometimes. Okay, this is one of those. Okay? Not horrible, though. Is that okay for you, Hannah? Now, Hannah, if you would, kindly, dear, read me I'm going to go into desmos.com. If you'd read me the original function, I'd appreciate it. Where'd that come from?
The title for the outside.
Mommy brought that?
No.
Jesse?
Well, Brooklyn's significant other brought that.
Oh, nice. Is that your lunch?
No. He got me a dollar bean burrito while he's gone.
Oh.
It's gonna be good. It's gonna be good stuff.
Thanks for asking, whatever. Anyway, so is it xy?
So it's yx squared.
What? xy squared? yx squared.
Yx squared. Plus ln times x times y.
Oh, you're going too fast.
And then plus
Hi, come.
4x over y
Over y.
equals
You're going too fast. All right, equals.
2x plus 5.
What? How cool is that, huh? Huh? That's pretty cool, isn't it?
Yeah.
Mr. Grimm, how far could I zoom out? I don't know. But notice that it may have a bit of an issue where the thing kind of comes back on itself, yes? You see that? Oh, hey, that's not a regular function that we know and love. All of our functions, they're not supposed to do that. They're not supposed to like bend around top of it because they're supposed to pass the vertical line test, aren't they? I feel like they are. Now, for instance here, Now this is one where, as I mentioned the other day in my video, if you watched it, that there could be an issue. You see this one here? It's not going to let me trace it. See, it hates me. Which is fine. A lot of people do. It's all right. What happens at 0, 0? Is it actually exist at 0, 0? And how would I know that? Well, I feel like the ln of 0 is what? I feel like it's undefined. Don't you think it is? I feel like it is. And so there's a hole there. Yes? So, but what I could do, I suppose, is graph a line that looks something like this. Y equals, no, 1 or something. What? And see what happens here. And I could probably get a pretty good idea of where, oops, stop it. That's not what I wanted you to do. Pretty good idea of what that value is, ish. But 1.3-ish, 1.39-ish or something in 1. You with me on that? Obviously, if I do this on the test, I will make sure that I pick a function that the thing will actually, that Desmos will actually graph for you. And yes, I expect you to use Desmos, okay, to check yourself. But listen, if you plugged in the point 1.39, 1, would you get a positive value or a negative value for your slope? Look at it. Does that have a positive slope right here or a negative slope? I know. So it better be positive, dog. That's what I'm saying. Mr. Grimm, what about down here? What about right in here? If I plugged in this value, which was like -2, -1.4-ish or something in that ballpark, really ought to be 0, yes? Ish, right? Because it's pretty flatter than a fritter right there. This is what we're talking about. It's what we've always been talking about. Now you're like, Mr. Grimm, could you actually do it for us? Could you plug in 1.39, 1? I don't want to, but I suppose I could for you, dear. Okay? So allow Mr. Groom to show you something really cool, if I can find the right calculator. If I had my TI-89 calculator, which, you know, is the bomb of a calculator. Someone read me the derivative, please. So it's parentheses, and what is it? What's the numerator there? X times Y or something? What is it?
-2x.
Oops, wait, stop. Times Y. Hey, go ahead.
1 over x.
Cool.
Minus 4 over y. Plus 2.
Oop. Plus 2. Divided by?
X squared. Plus 1 over y. Minus 4x over y squared.
Minus 4x divided by y squared?
Yes.
Okay. So I typed it in. You're like, yeah, good for you, Mr. Groom. Oh, wait. Check what you can do. The such that button, for my money, one of the coolest buttons on this machine. Watch me do this. Such that x equals 1.39. Bah. Now watch me go this. Grab this fella and go such that y equals 1. Bam! I got a slope of 2, dog. Now, what if I want to do it at a different point? Then evaluate at a different location. Oh my gosh, I love that so much. Because otherwise, what would happen if I had to plug in 3 or 4 different values of x's and y's? I had to do it by hand a bunch of times. I don't want to do that, Lil, because I guarantee you I will screw it up. Guaranteed. So I like that such that button. It makes me pretty happy. If you do not have your TI-89 on your Droid mobile device or have your own calculator, and you think that you might do something more with calculus, this would be a good investment for you. If you would like to borrow one to use during the class period, you may do that, of course. But that's all. Okay, here we go. Let's try another, shall we? So, the other day you did one of these jobs too. I don't know. For instance, the cosine of x times y plus 2 e to the 3x over y. No, I don't want to do that. That's gross. Oh, e to the 3x. Sure. Plus, no, equals. Right. Clearly, you cannot solve for y here, yes? It's not possible because you have to get it out of the cosine, which would put this inside of an inverse cosine. That's not going to work. That's just weird. Let's graph it for fun and see what's up. All right, so what was it? Cosine of xy? Okay, oops. And then what? Plus 2 e to the, and then equal y over x. Oh, dude. That's what I'm talking about. Huh? Nice. Isn't that cool looking? It's so pretty, Mr. Girl. It's so beautiful. Now, if you look at this function over here, is there anywhere where it has a problem? You know, it has a problem when x is equal to 0, doesn't it? Right? The original function has a problem at 0. Yeah, so will its derivative have a problem at 0 as well, yes? So it'd be really nice if I could trace this and find a place where it actually does it. And I don't think it's going to like me do this one. I don't think I care either very bad. How do I do y equals 2, just for fun? Yeah, so it's not going to let me graph it for sure, but it's going to be pretty close. I could see it right along here. 0.3, 0.31-ish, 0.3-ish. Are you with me on this? Yes? Not horrible, it's not great, but 0.3-ish. So if I did that, it's obviously a positive slope at this point, yes? What would happen right here at this point right here? At the top of that little, well, not there, stupid. On the top of this little rosy deal right there, what would the slope be? Yeah, positive, 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 0, negative, negative, negative. And then you're like, oh, wait a minute. Wait a minute. Right here is what kind of slope? Right here. On the front end of that knob. Undefined. Because it's a vertical line, yes? And then it's like, oh, wait, that's positive slopes again, isn't it? Because we always look at a graph from left to right, yes? All right, so let's go take the derivative of this guy. Just for good times. So what's the derivative of this fella? How do I do it? Chain rule, right? What is it? What's the derivative cosine of x minus of xy? You're killing me. What's the derivative of cosine? Negative sine of xy times, what's the derivative of x times y? It's 1y plus x dy dx, yes? Because it's a product rule. Plus, what's the derivative of 2 e to the 3x? Is it a chain rule problem again? I feel like it is. So it's 2 e to the 3x times the derivative of 3, which is 3x, which is 3. So it should be 6x, yeah. And then look, oh, Jude, check it out, dog, it's a quotient. So it's 1x minus y, no it's not. It's x dy dx minus y over x squared, right? Yes, Brooke? Yes? You hurt my feelings a little bit. It's not like math's my kid or anything, but I feel like you guys get a little more excited about it or something. It's not like you insulted my child or something. It hurts my feelings just a little bit. Get a little excited about it, dog. It could be worse. You could be in English class or art class. Or I don't even know. I mean, God, think about all the crappy classes a person has to take in high school. You could be in any one of... There you go! You could be in any one of those classes. But no, you're in calculus. It's awesome. You should celebrate that. Don't laugh at me. It's true. You should. What? Oh. It's not too bad, is it?
It is pretty long, but it's not hard. You know, I'm doing them all wrong.
Look, I'm not going to say that the coefficients aren't pretty. They may not be pretty, but the how to do them isn't bad. It's not bad. With Laplace, they're not that bad. Just expand. All right, now where are we at? All right, what's the next step, people? What's the next step? Which side do you want the dI dx to be on? The left, she says. She says she wants them on the left. I says, all right, I'm not going to argue with her. She kind of scares me. Is that right? Good for me. Personally, I wouldn't have done it that way, but you do what you want to do. You like all these blessed negatives. You just have a good time with it. Just me. Right? Mr. Groom likes to count. 1, 2, 3, 4, 5 terms, yes? 1, 2, 3, 4, 5 terms. I got them all. It's easy to lose one. To divide by this fella right here. Now, I feel like a minute ago we said that there was going to be a problem when x is 0. Didn't we say that? I feel like we did. What would happen if x was 0 right here? You'd have a 0 in the denominator, wouldn't you? Oh dear, that's a problem. Plus we're also dividing by 0 here, which is a mess, but really that's up on top, so it's not as big a deal. But then you're dividing by 0 up here, which is kind of a big deal. Point is, it's a problem at 0, just like we said it would be. Yes? Yes. Okay? And so voila, there we go. There you be. Ta-da! Now, what do we say? X is 0.3 or something. And y is 1 or some such. We could literally plug those into there, yes? And we'd get a value out. And again, it should be positive or negative, looking at the graph. Right here. Positive slope or negative slope? Positive slope. Literally, I think you're right. So let's try that. Parentheses, negative y divided by x squared. It's e to the 3x. God, my gut hurts. Nice. Such that x equals 0.3-ish. Clear, grab that fella. Such that y equals 1-ish. Slope of 7.47. Does that seem like it's reasonable, even-ish? Look, I might have a slope of 7 right there. Feel like that may not be wrong. Now Connor says, Mr. Groom, I feel like we could make a tangent line at 0.31. I feel like we could. You're not wrong. So 1 would equal 7.47 times 0.3 plus b or some such, yes? Whoops, that is not what I said. There we go. So b is negative 1.24. So then if I were to graph that, what was it, 7 point something? Minus 1.24 or some such. See, that's pretty close. Notice how we're off a skosh? That's because it's not exactly 0.3, is it? Are you with me? But does that purple line look pretty parallel to the green line? Pretty parallel. That's not perfect though, right? It's because, again, my x was a guesstimate, okay? That's a tricky thing about these guys, trying to find points that are exactly on the graph. Unless you, as a teacher, go, I will make this constant on the other side so it works out to be exactly 1, 2 on the graph. That's pretty cool. Which I do for the test, and the books, of course, do, because that's what they do, try to make the problems easy, but I don't really care when I'm making these problems up, okay? So, you mean we're going to have to find where they're positive and negatives sometimes? Yes. We'll have to find tangent lines? Yes. What is the whole point of this? I'm glad you asked. Tomorrow? No. Yes. Yes, tomorrow. Tomorrow, we are going to learn how to take the derivatives of, well, we're not, you are. I'm going to make a video tonight, I guess. Hey, Mr. Groom, I would like to know, what is the derivative of arctangent? It's a good question. You know how you do it? You have to use implicit differentiation. And so we're going to do that tomorrow. Okay? Furthermore, arc sines, there's some other ones. Ooh. No, there's another one. There's some other ones we'll look at that are kind of crazy ones like this. By the way, this is how we'll do it, just for fun, just in case you wanted to know. Y is the arctangent of x. That's the same as saying x is the tangent of y, yes? Oh my gosh, look, it's y. And where is he? Inside of a function. Oh, what the heck? Let's do it, Brooke. What's the derivative of x? What's the derivative of x? By God, it is 1. What's the derivative of tangent? Secant squared of y times dy dx. Yes? Wait a minute. I should then divide 1 over secant squared x. But wait a minute. Isn't secant 1 over cosine?
Wait, why is it secant squared of x? Why is it?
Why? Now, isn't secant 1 over cosine? So if you did 1 over cosine, isn't it just cosine? I feel like it is. This is the same thing as saying the cosine squared of y. What's y? I'm glad you asked. Let's look at this picture right here. When you say something is equal to the tangent of a value, that means this y guy right here is an angle in a right triangle, is it not? Maybe a 45-degree right triangle. I don't know. But this would be y right here, yes? Because he is the angle. That's who you take a tangent of, after all, isn't it? Thank you. Of course I'm right. Thank you. You hurt my feelings. Okay, now, friends, that's true. Wait a minute. The tangent is opposite over adjacent, is it not? Yes? So you're saying the tangent is x over 1. That's what you're telling me. That's what I'm hearing you say, isn't it? Yes. Wait a minute. If I do this, of course I want to know this, which of course is the Pythagoras Theorem. I believe you've heard of that, yes? You're not impressed yet, are you? Suppose I asked you, what is the cosine of y? What would you tell me? Lacey, what is the cosine of this angle y right here? For God's sakes, are you awake? Listen, people, listen. Sokatawa. Say it. Joshikau. Because why wouldn't you? All right, what now? Come on. Cosine is who over what?
1 over.
Thank you. Over that mess. That's right. But Mr. Grimm, I want cosine squared. Then you can have cosine squared. And what would it be? Be 1 over x squared plus 1 is equal to this fella. You mean to tell me that the derivative of the arctangent of x is 1 over x squared plus 1? That's what I'm telling you, Hoss. That's right. Every single one we do tonight will be like this. We will draw that triangle out. I can tell already, some of us, and I'm not going to mention any names, Lily, are not going to be terribly motivated to draw that triangle. I was not, literally was not that motivated. You know how many I messed up? A lot! Because the triangle is where it's at, dog. The triangle is where it comes from. You must draw the triangle. But Mr. Grimm, what if it wasn't arctangent of x? What if it was of 3x? That's aight. That would mean this would be 3x, wouldn't it? Ah? And that would mean this would be 3x, wouldn't it? And then I feel like this would be 9x squared plus 1. Ta-da! And we're going to work through that, and you'll be like, oh my gosh, that's not very hard. It's not very hard. It's not very hard. Okay? And you'll see those as we go along. It's going to be a good time. Some sort of. Not really, sort of. Okay? Now, we will play with these quite a bit in your little video. We're going to do arc sine, arc cosine, all that good stuff. Several other ones that need to be done this way. You'll be like, oh, that's not that hard. It's not. We will do derivatives of arcsines and arctangents a little bit, and so we'll do some examples of them. Some of them will be actually mixed up in other problems. So wait, you mean to tell me, Mr. Grimm, do you mean to tell me that we could run across one of these on the test? I'm not saying I'm going to do this problem. I'm just saying, could this problem show up on the test? Duh. That's implicit differentiation. With a product rule. This is implicit differentiation with chain rule. This guy over here, oh, it's the arctangent stuff. Oh, nice. But we just did this one, so we know this one is literally just 1 over x squared, 3 over x squared plus 1. We'll get to that, I promise you. This one, you're going to be like, oh, this is easy. It's just going to be 2y plus 2x dy dx is equal to 5 cosine of y dy dx. Do you want to go left or right this time? You want me to surprise you? I'm going to go right this time. I'm just going to go right. Because I'm right-handed, I think. I don't know. I swear, it doesn't feel like you're awake yet. Are you awake yet? Are you okay? Do you not have enough lunch? I mean, my tummy's rumbling. Maybe that's what your problem is. Is that what your problem is? I feel like my tummy's completely empty right now. It's just like it's angry and hangry, yeah? Hannah Morse taught me that. Are you hangry? No, I'm pissed off and I'm hungry. Well, that is literally the definition, Mr. Grimm. Oh my gosh, weird. Okay, yeah, there it is. So yes, we will run all this math together. There'll be products, but there'll be quotients inside of chain rules, and oh my gosh, it's just awesome. Because why wouldn't you? Right? Why wouldn't you? So that pretty much takes care of that. You got the rest of the period to work. You should ask questions and so forth. But I think if you've practiced it all, you should feel fairly confident. It takes a little while to get used to these guys. Unlike when I was taught it, it was like it was some kind of, it was a little bit of a magic show, to be honest with you. And it wasn't real clear why this dy dx was floating around. At least it didn't seem like it was real clear. But it's a placeholder in that regard. But we just know that it is a function of x. If I knew what it was, if it was x squared plus 2, I'd just substitute it in. But I don't know what it is. So because I don't know what it is, I have to just keep track of it. It's all right. Nothing wrong with that. All right. Alright, so enough jibber-jabbering. Get some work done. I'll be around to help you if you need help. Actually, I'm going to go sit at my desk. You can wander over and ask me if you need help. Alright. You got lots of time.